limiting reagent and percentage yield, taking into account stoichiometry. After 225 grams silicon tetrachloride and 225 grams magnesium reacted, 35 grams silicon was isolated. Now you need to calculate first what is the percentage yield of the reaction, how many grams of the reagent in excess will remain. You need a balanced reaction equation to determine the stoichiometric coefficients. Silicon tetrachloride reacted with magnesium to form silicon, and of course magnesium chloride. Balancing of reaction by literally just counting the atoms to the left and to the right, you find that 1 mole of silicon tetrachloride reacts with 2 moles of magnesium to form 1 mole of silicon and 2 moles of magnesium chloride. You receive the information that you've got 225 grams of each of the starting materials. What you need to do is then, you must ask yourself, have I got enough magnesium to react with all the silicon tetrachloride present? And you're going to compare silicon tetrachloride with magnesium, taking into account the conversion factor, the stoichiometric coefficients. Express 225 grams silicon tetrachloride as the number of moles by taking into account the molar mass conversion factor. Going to your periodic table, sum the molar masses of the different elements. 1 atom of silicon plus 4 atoms of chlorine. The molar mass, 1 mole, will weigh 169.898 grams. What you do is cancel the gram unit and stay with the mole unit. So 225 grams of silicon tetrachloride represent with 1.3243 etc. moles of silicon tetrachloride. You will need twice this amount of magnesium. So you will need 2.64864 moles of magnesium. What you need to do is you need to ask yourself, have I got enough magnesium to react with all the silicon tetrachloride? Have I got 2.6 moles magnesium? You calculate magnesium. You've got 225 grams. You represent that as the number of moles using the molar mass. 1 mole magnesium will weigh 24.305 grams. Gram units cancel out. And you calculate this to be 9.25735 etc. moles. So yes, you have got an excess of magnesium because you only need 2.6 and you have got 9.25. So you've got an excess magnesium, which will imply that limiting reagent is then in fact silicon tetrachloride. This means, if you look at your reaction equation again, that silicon will be determined by all the silicon tetrachloride present. Silicon tetrachloride is the limiting reagent. There is more than enough of magnesium present to react with all of this. And in actual fact, some of the unreacted magnesium will be left. You need to compare then silicon tetrachloride with the formed silicon. Looking at the stoichiometric conversion factor, 1 mole of silicon tetrachloride will form 1 mole of silicon. Relationship then 1 to 1. You've calculated that you have got 1.3243 etc. moles of silicon tetrachloride. You expect then 1.3243 etc. moles of silicon. Express that as a mass. Take into account the molar mass of silicon. Molar mass of silicon, this is now mole silicon. Molar mass is, using the periodic table, 1 mole will represent 28 grams. You get rid of the mole unit, you form the gram unit. Therefore, 37.1949 etc. grams of silicon is expected. It is the expected or theoretical yield. Looking at the information given, the information says that only 35 grams of silicon was isolated. So this is the expected, or we also call it the theoretical yield. Theoretical yield. You did not isolate 37 grams. You've only isolated 35 grams. So we express this as a fraction in terms of percentages. You've isolated 35 grams of silicon. You expected 37 grams. And when you express that as a percentage, you see that you've isolated only 94.09876%, and now you round it in terms of significant figures. Altogether 3 significant figures, it will be 94.1%. To calculate the excess magnesium, it will be the difference between what we've started with, 9.257 moles, minus the magnesium consumed, the magnesium needed, 2.6486 etc. moles. We have got thus 6.608706 etc. moles excess magnesium. Express that as the mass by taking into account the molar mass, and this will be 160.6246 grams, rounded to 161 grams.